Assalamualaikum warahmatullahi wabarakatuh. Today our group will be discussing about application of differentiation. This is a group assignment for course code MAT183 for students who take part in Diploma of Pharmacy PH1102 under Sir SHAHIRAH bin Yahya. First of all, let me introduce our group members. Our group consists of 3 students. Leading the group, we have SARA NABILA binti Muhammad IZHAM. Next, we have NURUL SHAHIRAH binti NAWI. And lastly, me, SYAFIQAH binti RAMZAN. I will begin the presentation with my slide, which consists of what is differentiation, when do we apply differentiation, and introduction to related rate. In application of differentiation, we have to know what is differentiation. So we can find rate of change by using differentiation. It enables us to determine the rate of change of velocity with respect to time, which is acceleration. It also allows us to calculate the rate of change of x with respect to y, which is the gradient of the curve on a graph of y versus x. There are a few basic principles that may be used to easily differentiate a variety of functions. If y is equal to some function of x, then the derivative of y with respect to x is written as dy over dx. Next, we want to know about when do we apply differentiation. We apply differentiation to find the rate of change and also to analyze the function involving increasing, decreasing critical point, concavity, and inflection point of a function. We also apply differentiation to analyze a function concerning relative extrema, first and second derivative tests. We also apply differentiation to apply maximum and minimum problem, and to understand Rolle's theorem and mean value theorem for differentiation. And lastly, I will present about the introduction to related rate. In a related rate issue, two or more variables change at the same time, perhaps at different rates. We can figure out how the variables are connected and how quickly one of them is shifting. If we know how the variables are related and how fast one of them is changing, this usually includes creating an equation, connecting the two variables, and figuring the equation's derivative with respect to time. That is all for my slide. I will hand over the presentation to Sar Nabila to continue the discussion on objective or related rate.
And I'll be continuing SHAHIRAH presentation and starting the objective of related rates. So, firstly, objective of related rates is to find the rate of change of one quantity knowing the rate of change of another quantity. This is generally for all of related rates question. So as we know, we go straight to the problem statement of related rates. In this question, the volume of water in a hemispherical bowl of radius 30 cm is given by V equal to 1 over 3 pi 26x square minus x cube, where x centimeter is the depth of the water. If the water is poured in at a constant rate of 10 centimeter cube over second, at what rate is the level rising when the depth is 8 centimeter? From this statement, it has stated that the volume of water have been given an equation. So from that equation, we can differentiate and find the rate of the level rising. So the radius is also given as it will be a big point for us when answering the question. So for number 2, a boy is blowing a spherical balloon at a rate of 50 centimeter cube per second. At what rate is the radius of the balloon change? The radius is 10 centimeter. From this equation also, they have given us the volume of the balloon inside the balloon, which is 50 centimeter cube second. So at this point, the clue given are a big shot for us when answering the question. So this question ask for the rate of the radius, and if the balloon change the radius is 10 centimeter. So from this question, they have given so much clue to help you answer. So objective of those related question before. For question 1 is we have the volume, so we want to find the rate when the level is rising. And for question 2, we also have the volume of the balloon, so we want to find the radius of the balloon. So I'll continue this presentation to Nurul Shahira. Thank you.
Hello everyone, my name is NURUL BINTI NAWI. My matrix number is 2020852224. And right now I will be explaining the problem solutions of those two questions that have been stated and also the conclusion of this topic. For question 1, it has been given that dV over dt is equals to 10 centimeter cubic over second and the value of x is equals to 8. Right now we have to find the value of dx over dt by using chain rule. So the equation will be dx over dt equals to dv over dt times dx over dv. We already got the value of dv over dt. So right now the value that we have to look for is dx over dv. We will be using the value of v, which is pi over 3 times 36 x squared minus x cubic. We will differentiate this value and it will become as pi over 3 times 72x minus 3x squared. Then when we got these two values that we need, we just need to put the values inside it. So it will be 10 times 3 over pi times 72 times 8 minus 3 times 8 square. We will calculate these values and we will get the final answer, which is 0.025 centimeter over second. For question number 2, it has been given that dV over dt is equals to 50 centimeter cubic over second and the value of r is equals to 10. Right now we have to find the value of dr over dt by using the same technique, which is the chain rule. So the equation will be dr over dt equals to dv over dt times dr over dv. We already got the value of dv over dt. Right now the only value that we need to find to use this equation is dr over dv. So we will be using the value of v, which is 4 over 3 times pi r cubic. We will differentiate this, it will becomes as 4 pi r square. And then after we got these two values, we just need to put these values into this equation. So it will be 50 times 1 over 4 pi times 10 square. The reason why we change this values is because the value that we got here is actually dv over dr, and the value that we need in this equation is dr over dv. So after we calculate these values, the final answer that we will get is 0.04 centimeter over second. So this is the final answer for question number 2. So the conclusion of this whole topic is the rate of change of one quantity, knowing the rate of change of another quantity, can be found by using either chain rule or implicate. So that is all from our group. Thank you so much.